baştaki neyle ilgili? Causal system. Bunu daha önce sormuştu arkadaşlarınız. Okay, I'm going to switch to English by the way. I'm sorry. Okay, there were some feedbacks from you. One was about causal system. Some students reported that they do not understand causal systems. So I have a question regarding causal systems. This is a question, sorry. Question number 218. Okay. From the textbook. LTI system. We have some LTI systems and causal or not. Question about some LTI systems. Their impulse responses are given and they ask whether they are causal or not, or show whether causal or not. Part A, h of n is 1/2 to the n u of n. Okay, whether this is causal or not. Now let's remember a causal system. A system is causal if h of n is 0 when n is less than 0. Okay? So, how about this system? Okay, let's see impulse response. It starts from 0. Okay, so 1/2. So it starts from 1 and goes down. It decays exponentially. So it is 0 when n is less than 0. Okay, right? So it's 0 here. Then that is causal. Okay, I have some other parts, but I have chosen part E, where we got an h of n, which is 1/3 to the power n u of n plus 3 to the n u n minus, sorry, minus n minus 1. Okay? Let's see. Let's plot it. The first part, it's u of n, so so it's very similar to part A. So it's n, here is 0. Now it decays, right? So that's first part. How about the second one? It's minus n minus 1, which means that, okay, let's take here is 0. So when n is 0, let's see u of n first. U of n is u minus n minus 1. So it starts from minus 1 and goes to infinity, right? Minus infinity. And it's multiplied 3 to the power n, so it's going to be decaying, right? Like this. So this seems to be causal. So this is not causal, term by term. So together, this is not a causal system. okay? Because its impulse response is not 0 when n is less than 0. Next, problem number 290. It's about stability, stable systems. Stable or not. There are several parts here. I will start part A. And h of n is given 4 to the power n u of n. Now let's remember stability. H of n is stable or not h of n, but the system. System is stable if h of n is absolutely summable. That is, we sum h of n absolute value. If this is not infinity, then the system is stable. So we have to add all the values of h of n, get the magnitude, and then if it is summable, if it is not infinite, then the system is stable. So let's see this impulse response. What will happen here? For, okay, let's draw it. Zero, 1, and then decreases. Sorry, increasing. I'm sorry. So okay, so here is my impulse response. If we add them up, so we simply get 4 to the power n, which goes to infinity when n goes to infinity. Okay, so this is not stable, right? Not stable. Let's see part C, where h of n is 3 to the power n u minus n minus 1. Okay? So let's see. Let's plot it. This is u of n shifted, it's folded and then shifted by 1. If this is 0, so it starts from minus 1. So it goes like this. The first value here, 3 to the power 0, it's going to be 1. So it's a decreasing function, right? So summation of h of n absolute value is going to be, it's normally from minus infinity to plus infinity. So here it's going to be minus infinity to minus 1, right? 3 to the power n. So let's use our well-known identity, which was n1 to n2 alpha to the power k, which is alpha to the power n1 minus alpha to the power 2 plus 1 over 1 minus alpha. So I can use this here. Then it's going to be, we can also write this as this is left-hand sequence. We can make it right-hand sequence starting from here +1, for example, and goes to infinity, or we can write it as is. If we can convert it into the positive side, we can write this alternatively from 1 to infinity. So just mirror image of this sequence on the right-hand side. That's going to be 1 to infinity, which is 3 to the power minus n. Okay? Or 1 over 3 to the power n. They are equivalent. Then this is going to be 1 over 3 minus 1 over 3 to the power infinity divided by 1 minus 1 over 3. So this goes to 0. And then it's going to be 1 over 3 divided by 3, 2 over 3, which is 1 over 2. So that is going to be stable sequence. Okay? Now we have one more sequence to inspect whether that's stable or not. Part F. So let's divide the screen. Part F, where h of n is 2 times u n plus 5 minus u of n minus u n minus 5. Okay? Now, let's see. Let's plot this sequence first. Take one by one. Okay? Here is the axis. And I have unit step function here. Let's make it blue. Right? This is u of n. The first one, so it is from minus 5. So minus 4, minus 3, minus 2, and minus 1. So it is from here, but the magnitude is twice. So 2 times. Okay, so this is 2, this is 1. Next, I have the third sequence. Let's make it green, for example. So it's going to be 1, 2, 3, 4, and 5. So it starts from here. Okay? So I need to get the differences here. This, note that this black one goes infinity. Okay? So I have to subtract from this black one to blue one first and then green one. When I subtract both, so somewhere after this, right, the resultant sequence will be 0 after 4. Okay? So it is 0 right, when n is greater than 4. Okay? When is n in between 0 to 4, Okay, so we get the difference. So it's going to be 2 minus 1, 1. So h of n is going to be 1 when n is in between 0 to 4. Okay, and between minus 5 to minus 1, so here it's going to be 2. So h of n is going to be 2 when it is n is from minus 5 to minus 1. So then if I want to look at the summation h of n absolute value, I have to add them up from minus 5 until 4. Okay, which is a constant, right? A constant. No need to calculate that. It's quite easy, but you don't need to do that. It's a constant. Then this system is a what we call stable system. Stable. Okay. So this is about causal and stable systems. Next, I suppose that you can take a screenshot. I recommend you take a screenshot if you want to study later. So I'm going to clear the board. Let's stop sharing.